So this recording is because due to the inclement weather policy of TCC, we are not having the graphing lab tonight, which obviously was supposed to be Zoomed anyway. But since we have been directed to not hold classes anyway, then this is supposed to serve as something you can watch. In fact, you can watch it several times if you want, and email me questions regarding usage of Excel and that sort of thing. So loaded into Canvas, there is a document for the graphing assignment. So let me show you what this looks like. All right, so this is the 112 graphing exercise. And the beginning part of it involves using some gas laws. So think about the fact that if you are calculating the number of moles, you are supposed to make an assumption that you have a number of grams based upon that. So you have 3.26 grams of CO2. You are given the molar mass of 44.01. You need to convert from grams over to moles. This is just like things that were taught during first semester. Then we move on to the ideal gas equation. Now, the ideal gas equation is PV equals nRT, but we are going to use a different value for the R than tends to get used during first semester. First semester usage of ideal gas law generally involves 0.0821 because the pressure is in atmospheres. We are going to change that pressure over to millimeters mercury. So let me flip over to my whiteboard. So we are using this equation. We are using P V equals nRT. Actually, the N should probably be lowercase. All right, so your R value then for this, because it is in millimeters mercury, is going to end up being bigger than you probably originally have gotten sort of used to using it. So let me flip back over to the whiteboard. So we've got 62.37. I don't use this particular version of it very often. I'm double checking my number here. So you are given a number of values for temperatures. So step one being that, okay, temperatures must be in Kelvin. So T must be in Kelvin. Spelled Kelvin correctly. So you need to do Celsius plus 273. And that will give you your Kelvin values. All right, back over to the other document then. So you are given a volume of 2 liters. You will calculate your N from the above, put it into this equation, convert your Celsius over to Kelvin, and then solve for pressure. So let me give you some approximations on how this math goes. So we are looking at the idea here. Let me clear this off so that we have, if you have 0 degrees Celsius, so 0 Celsius, so plus 273 is going to give you 273 Kelvin. And so by rearranging all of this, since you are solving for pressure, the P will be equal to the NR, and then you would put your value in for your temperature. So in this case, it's 273. And then all of that gets divided by your 2.00 liters. I could even go back in and sort of redo this a little bit so that you're actually seeing the 62.37 value for your R. So N times R times T divided by 2 liters will give you your pressure values. All right, so once you filled in your table, then we're going to use Excel to generate a graph. So this is what your Excel spreadsheet looks like. And actually, I'm clicking on the wrong thing here. So share screen, spreadsheet. All right, so this is your spreadsheet. I am going to create some artificial data for you. This is actually not the data that you're going to be using. We're going to do temperature in the first column, and we are going to do pressure in the second column. And then I'm going to start with the 273, but then I'm just going to invent some other numbers here for us to use. So 273, 281, let's do 289, 292, 297, and 312. Okay, so we have a handful of temperature values. So your pressures, okay, think all the way back to Charles' law. Actually, yeah, Gay-Lussac's law, pressures and temperatures. So the higher the temperature, actually, I realized I put a 3,000 in there instead of just a 312. As you increase your temperature in a fixed volume, in this case 2 liters, your pressure will go up. So I am going to also then invent some numbers here for doing this. So we're going to say that maybe pressure is 405, and this is in millimeters mercury. So if that is my first set of values there, so then 281, and I'm going to give you a 399 as your pressure there. And actually, let's see, we'll do 289. That will give me 439. Actually, I need to go back and change this one. Otherwise, it's going to give me something kind of weirdly not linear. I'm trying to invent some data off the top of my head that will give you something that looks kind of normal-ish. So 292. And that will give me 1. And then we'll have 297. And that will give me 454. And the last one, 312, will give me 460. All right, so I have data. I am going to go up here to where it says insert. Okay, I hit on my insert. You see all these things across the top. I want a scatter plot. Okay, but before I click on the scatter plot, I am going to highlight my 2 columns of data there. Otherwise, it won't know what to graph. So scatter, and I'm going to pick the one that has no lines. So it looks like this. All right. Then over here, look at all the little things that says chart layout. Okay, my suggestion is the easiest one to use is usually the first one. Okay, this will give you a chart title. The idea being here that you should have a label for your graph. So we are just going to do pressure. Oops, I clicked too many times. Pressure versus temperature. Okay. My axis title. So look at these numbers. These are all the ones that are the pressure. So this is my pressure. Specifically, it is in millimeters mercury. Okay. Then I've got an axis title down here. So I've got temperature, and this is in Kelvin. Okay. Note, there's no line on the graph. Many of the graphs that you do this semester are going to be what they call best fit, also known as linear regression. So I am going to position my cursor on one of the dots. Right hand click your mouse, add trend line. Okay, it pops open this box here. We want to see the equation because many of the graphs that you are doing this semester use values of your slope as an important piece of your information. But I also want you to check the box that says R squared. What does R tell you? What does R squared tell you? Kind of tells you how good your data is. So let me close this. Okay. I have kind of meh data. Look at your equation there. We have y equals mx plus b. Your m is 1.6079 x. Okay, so that's your slope. My y-intercept, the plus b, is negative 33.024. I would prefer if my r was 0.95 or better. Okay, think of it as kind of like 95%. The idea being that the R value gives you some input as to how good or how bad your data is. So let me see if it will let me change my data here just a little bit so that I have slightly better data here. So I change my 460. Let's do 461. Okay, that changed things a little bit. If I change the one that corresponds to 281. So let's do 410 on that one. Obviously, you're going to calculate stuff in your graph, but I'm just trying to optimize it so I can show you what it does to the R value. So I made my points a little closer to the straight line. Look what it did to my R value. It made it a little bit higher. So if I had this data, 405, 410, etc. I have a little bit closer to a straight line in terms of how my data is spread around. So being able to use the dropdown and generate your graph is kind of the big key here. So the front of the page, you are graphing pressure and temperature, do your trend line. All right, let me flip back to the other document here. All right, so on the back or the second page, we have kinetics. So you are going to have to take, okay, ln being the natural log. So take the natural log of your concentrations. You will have numbers to put in the blanks there. When you use the graphing function this time, you are going to use the ones that connect the dots. Okay, so let me flip back over to my whiteboard here again. When you draw this graph, okay, there's your graph lines. This time around, you are not going to get a straight line. When you connect the dots, you're going to get this. Okay, you're going to get kind of a curvy bit there. Let me pull up some actual real data and kind of show you how the connect the dots part works. All right, so here's some real world data. Okay, I have values down the side here. Okay, these are number of days. I have ferritin, which is a way to measure how much iron is stored in your blood. And I graph the data. And I used the insert and the scatter. And then when I did it, I told it to connect the dots. Okay, I picked the one that had the little squiggly line. Okay, hence it didn't draw a straight line here. It just connected all of my data points. Okay, so I ended up with a rather erratic looking graph, but it's based upon the fact that I have relatively erratic data. If I go back over here to this one, I'm just going to kind of clear everything out here. And put in some of the things that it asks you to do for that second graph. You are graphing time. Okay, why can't I actually get it to delete here? I'm just going to switch pages. That's kind of easier. So I'm going to put time seconds, and then I'm going to graph my concentration, the H2O2. When I go back here and look at my data, I have 0.862 as my first value. So 0.862. And then I have an, oops, I shut one of my documents there. The time for that is time 0. So 0 time. Okay. We have a decreasing amount of the concentration because it's getting used up over time. We've got 0.556. So 0.556. And you have, I believe it is 120 seconds there that you are dealing with. And then we have 240. We have a lower value there. We have 0.394. So highlight only your numbers. Don't highlight the wherever you put your words. Okay, scatter. Pick the one that has the dots connected. And this gives you not a straight line. Okay, so I would go back then also and label this and tell you what it is. So make sure you put in chart title. Make sure you put in an axis title for the vertical axis. Make sure you put an axis title in for the horizontal axis. Okay, so all of those bits are ways to utilize Excel. You are not required to make it do the math for you. If you know how to do that, great. Okay, but we are focusing on using the Excel to actually generate your graph for you. For the second graph, I'm gonna swap back over here to the other part here. So once you are doing the next line, okay, see here where it says create natural log of H2 versus time. So you are graphing the third column versus the first column. This one you must use a trend line for. Make sure you hit the R value and make sure you hit the display equation. Once you have generated your graph, okay, here is the how you use that equational data. If you put 200 into your Y value and then calculate your X value and anti-natural log it, you will get a calculated value for your concentration. But look at your data here. So you're looking for a time that's at 200 seconds. So one way to judge whether or not you're headed in the right direction is look at your data. So at 120, I have a little over half a mole. At 240, I have 0.39 molar. So if I picked a value for 200, your answer should be less than the 0.556, but more than the 0.394. The final piece of data here, or the final piece of calculation is do the graph again, but do it on an actual sheet of graph paper. Take your straight edge, your ruler, or anything with a straight edge. Do your best eyeball fit. And then see what it seems to indicate your value is for the 200 seconds. It will not be the same. Best guess eyeball fit is never quite as good as the calculations that are done by the trend line. But on the other hand, it should not be vastly and exceedingly different. This is my best guess at a way to get you this information. Like I said, send me email regarding questions. You have got to be able to graph for this semester because a great deal of the upcoming labs require data fits. Okay, you have to be able to graph your data and then figure out what the equation is. And really, the only decent way to do that is to use Excel, like I said, or Google Sheets. So this is a really key tool to the things that we are doing this semester. I will hopefully get this translated and posted to YouTube. And then I will put the link so that you have the entire week to watch it. And then hopefully I'll spend a little time answering some questions next week, when hopefully we have no snow and we can have our final Zoom lab, fingers crossed. I hope this helps. Send me questions via email if you are totally stuck.